Hello students, my name is Dr. Anil Mangla and today the question we will solve is on differential equations. So the question in hand is, there are two pipes connected in a tank which contains 1000 liter of brine. Brine contains 0.1 kg per liter of salt flows in through pipe 1 at 10 liters per minute. So I will make a schematic so that it can be understood. So there is a tank, its volume is 1000 liter, it can be more, but initially it contains a brine that is 1000 liters, and there are two pipes connected to it. Okay, so from one pipe which the brine is coming, that contains salt of 0.1 kg per liter, and the flow rate is 10 liter per minute. Similarly, while another brine containing 0.2 kg per liter of salt flows in through pipe 2 at 10 liters. Another pipe is throwing 10 liter per minute brine, and contains 0.2 kg per liter salt in this. And there is a stirrer in it to make this solution homogeneous, uniform, and flows out at the rate of 25 liter per minute. And the concentration is not given, but whatever it is here, that will be here. So let's say that will be here. So let's say it is, the concentration is Ct, that is concentration at time t. Here also the concentration at time t. It is given that C30, the concentration at 30 minutes when this started, it is equal to 0.6 kg per minute. Okay, and we need to find the concentration at 20 minutes after this process has started. 20 minutes after this process has started. So we will first, we need to model this situation. So that model will have concentration C and its derivative, similarly volume and its derivative. So there will be, so the equation which contains this, that is called differential equation, which I will just tell you how to do. First, let's mark them. Let's say this is V1, that is volumetric flow rate from pipe 1, and this is concentration 1, that is concentration in the pipe 1. Similarly, this is C2 and this is V2, volumetric flow rate from pipe 2. This is volumetric flow rate from pipe V3, which is basically outlet, and this is C3 at concentration, and it is equal to C2. Okay. Now we will write a differential equation. For that, the basic information what we need is, there is first volumetric balance, or it's called it is also called a brine balance, the solution balance. So whatever is coming in flow rate minus out flow rate. This is a very basic equation, that is basically equal to change in volume, rate of change in volume. This is rate of change in volume. So since this is for brine, so it will give the change in volume of the brine. So what is inflow rate? This is V1 plus V2. This is V1 plus V2. And what is outflow? That is V3. So it will give us the change in volume inside this tank, that is equal to dV by dt. Let's say V is Vt, volume at any time, that is Vt. So we will put the values of these and we can find the, so this is a differential equation in the form of V, containing V and Vt's. So what is V1 plus V2? This is 10 plus 10, and V3 is 25 liters per minute, and that is equal to dV by dt. So this is equal to basically minus 5 equal to dV by dt. So we can solve this integration now by taking t here. So this is minus 5 dot dt is equal to dV. Now take an integration of it on the both sides. Since this is constant, it can go out. This is 1 dot dt and this is integration 1 dot dv. So this is minus 5t plus constant equal to v at any time t. Okay, so I will rub this stuff and directly get the equation, which is, so initially we know that at time t equal to 0, Vt is 1000. So we will use this here. Put time t is equal to 0 here. So we can get the value of k. This will be 1000 at time t is equal to 0. So minus 5 into 0 plus k is equal to 1000. So k is equal to 1000. So what we get? Now we get the Vt, equation for Vt in terms of time, that is 1000 minus 5t. This is our first equation, which is showing the change of volume of brine in the tank with respect to time. Now similarly we will take the salt balance. Earlier it was a brine balance. Now we will take the balance of salt, mass balance of salt. And I will write this equation Vt is equal to 1000 minus 5t. This is our first equation. Similarly, mass balance of salt is rate of salt in minus rate of salt out is equal to rate of change in salt amount in tank. This is a basic mass balance equation. So what is the rate of salt in? So concentration, use the concentration into volume flow rate. This will give the total salt that is coming in through pipe 1. Plus there is one more C2V2, and going out is C3V3, that is equal to change in the concentration of salt at any time, that is CTVT in the tank. Now we will put the values of this. C1 is 0.1 into 10 plus C2 is 0.2 into 10. C3 is basically CT and V3 is 25 equal to d by dt into CT is CT, because we need to get the expression of it, and Vt is, we have just found, that is 1000 minus 5t. And we will solve this differential equation. Simplify this. This is 1 plus 2, that is 3 minus Ct, 25 Ct, that is 25 Ct equal to, now we will apply the product rule on this. So first differentiate Ct and take this out, that is 1000 minus 5t into C dash t minus, then take Ct out and differentiate this. So it's a linear term, so only minus 5 will left, so put this minus 5. Okay, so I have to rub this. What we are left with is, I can rub this one also. What we are left with is 3 minus 25t is equal to 1000 minus 5t into C dash t. C dash t is basically dc by dt minus 5 ct. Take this minus 5 ct here. This is ct, not t. This is ct. Take this minus 5 here, then 3 minus 22 ct is equal to 1000 minus 5t into ct. Now we can separate the variables. This linear equation is in terms of, this is dc by dt. It is in terms of ct, and this linear equation in terms of t. So we can separate them. So this will give us 1 by 1000 minus 5t dot dt, and this will give us 1 by 3 minus 20 ct dot dct. So now we have separated the variable, and now we can integrate it easily. Since this is a linear form and it is in denominator, so the formula used will be for lnx, that is 1 over ax plus b dot dx is equal to ln of mod of ax plus b divided by a. So here a is minus 5 and b is 1000. Here a is minus 20 and b is 3. So what we will get is ln of mod of 1000 minus 5t mod. Why we apply mod? Because we need that this should be positive. Whatever is the argument of the ln, that should be positive. Divided by minus 5 is equal to ln of mod of 3 minus 20 ct over minus 20 plus constant of integration, right? So we can solve this. What we will get is 4 ln mod 1000 minus 5t is equal to ln 3 minus 20 ct plus one more constant. Let's say it is c dash or it is k. We need to find this value, and we have given one more initial a condition, not initial condition, that at time c, time is equal to 30 minutes, the c value concentration is 0.6 kg in this. So we will put this value here, putting t is equal to 30. So we will get the value of k. Okay. So when we will do this, what value we get is k is equal to ln 850 raised to power 4 over 9. Because when this is t is equal to 30, this will be 850, and there is a 4 which will become the power of it. And when this is ct is 0.6, when you will put it here, 3 into 20 into 0.6, it will give you 9. Okay. And you will get this, okay. And what else is 0.6? So 3 minus 20 into 0.6 is basically 1. This is 1.8, 1.2. So this will give you 1.8, and that 1.8 will become further. After solving this, we will get this value. That can be done easily, right? Because of the scarcity of time and place, I am avoiding this calculations. Okay. Now our equation. What is our equation? Is 4 ln 1000 minus 5t mod equal to ln 3 minus 20 ct plus ln 890 raised to power 4 over 9. 850 raised to power 4 over 9. We don't need to solve this, simplify it. What we need is C20. So put the value of t equal to 20 in it. We can get the value C20. So like 4 ln mod 1000 minus 5 into 20, that will give us 900. And since this is a positive number, so we can just ignore the mod. Similarly, this should remain positive, minus 20C20 plus ln 850 raised to power 4 over 9. So you can bring it here. It will give us, this will be subtracted here, so it will divide it. So this is 900 raised to power 4 into 9 over 850, that is also raised to power 4, is equal to ln 3 minus 20 CT. We can remove this ln because this is on both sides, so just remove it. And this is a positive number, and for this to be positive, because CT has to be positive, so this mode, this value should be less than 0, then only this will be positive. Okay, so this will become 20 CT, this will become 20 CT minus 3 equal to this number, because negative of this is greater than 0, or this is less than 0. So therefore a negative has been put in, and then it is multiplied with minus 1, as because using the property of mode. So this will give us the value of, after solving this 3 will come up here. This will be 3 plus this value equal, divided by 20. Let's say this is x plus 3 divided by 20 equal to CT. So this gives us the value of 0.7156 kg per liter. I hope the question the way I have solved the question, every step must be clear. In case of any doubt, please put it in a comment. And because of the scarcity of the place, I have skipped some steps. Thank you.